trying to see how I can get it to like really like. Let's see if it's yeah. Okay, good. This is good. So we have what? Okay, okay. So minus minus p2 equals to this. So bring it over. So we have this okay. Yeah, part 3. Okay. I would say part A is just some very basic stuff. Part B is the real deal.
Well, how do I find QT?
Where's QT? Let's take a look. QT.
QT is like an extension of the OQ.
Okay. Yeah, sorry. So let me just get my pen tool out. Just okay, good. OR this, then OP this, then OQ. Oh yeah. Ah, okay. So you need to use the similar triangle properties, I guess.
Oh, is it like OP over OS is equals to OQ over
OP over
OS?
OP over OS. Yeah, okay.
OQ over OT?
But the first thing you need to do is you need to prove that yes. So you need to prove that triangle OPQ is similar to triangle OST. Yes. Yeah. Then you can use the one. I think it's 1/3, right? Yeah. Yeah. Yes. So you need to prove that they are similar first. All right. And it's pretty easy, right? Common angle, right? Then parallel lines, if they are parallel, then this angle and this angle has to be the same, right? Right? Hello? PQ is parallel to ST, right? Yeah? Oh, sorry. I can't hear you. Okay, sorry. Just let me just correct my settings. So this thing is the problem. Always the problem. Can you hear me now?
Yeah,
Okay,
I
good,
can
good, good. Yeah.
always hear you.
Yeah, so they I don't know why this thing tends to mess up my I mean the audio is always the problem. I don't know why.
Oh,
Yeah. But never mind.
no, but my teacher said that
Mm,
if the question doesn't ask for proving of similarity, we
mm.
don't need to prove. We just state that it's similar.
Wow. Then what about those? Okay, I just assume it's similar, or I assume it's congruent.
But I don't know.
Never mind.
That's
I
what my
mean,
teacher said.
okay, I agree with your teacher. If the question never asks you to prove that, then you don't have to prove that. But some people they don't know how to prove, but they just want to um for convenience, then they just you know what I mean?
Okay.
Have you ever like asked your teacher, what about for those who just assume?
No, I haven't asked.
Yeah. Okay.
Okay.
Hmm. And sometimes, right, let's say, okay, for example, for convenience, we just say um something is similar to something. And then when you really want to prove it, right, you can't prove it.
Then I guess it's not similar.
No, so no, the thing is, no, according to your teacher, I don't have to prove it, right?
Yeah.
Yeah. But when you need to when you go and prove it, you can't prove. So
Oh,
you leave things to chance. What do I mean by that is like you assume it is similar. You assume this is similar to that, but you can't prove it. So you depends on your luck, right? If they are similar, good. Your assumption is correct. But if they are not similar, bad luck, right?
yeah, okay.
So it's better to prove it so that you have that assurance in yourself. So when you use the so if no what I'm trying to tell you is if you can prove it's similar, you can use the similar triangle properties. You use the similar triangle properties with confidence. Okay?
Okay.
If not, you always have that pinch of doubt. Okay? Okay? In you.
Okay.
Alright? So in a way, yeah.
Yeah.
I just want to know how do you get QT?
Is it? That's the question, right?
So OT, you use OT minus what? Minus O.
OT minus OQ.
Oh, okay. So OT is equal to OQ plus QT, and you're asked to find QT, right?
Yeah.
So you use OT minus OQ. Okay, good. Yeah, good. Because I can't see minus. I always do it. I always use addition. Okay.
I just
Yeah, somehow memorize it already.
no, it's because it's in a straight line, so I
Mm-hmm.
just like remove it.
Okay. OT minus OQ is QT. Oh, okay, okay. Yeah, thank you. Thank you. Yeah. So you try to look at the diagram and somehow. Okay. Can you plus these two together?
Always PS.
Yeah. So the second letter of the first term must match the first letter of the second term. Then only you can add them together. Have you learned matrix, by the way?
Yeah.
Okay. I think this is a bit like the matrix thing. This column vector is kind of like the matrix thing. Yeah. You didn't mention that to me until I realized it myself.
It was quite some time ago.
Sometimes for me, it's even further than you.
Oh.
Yeah. Okay. Good.
So it's not the numerical value. Oh, okay.
So just get rid of this. For you, sneezing is common, right? Like it's like a chronic uh, problem for you.
Yeah.
Do you like sneeze in class?
I do.
Oh, okay. No. Can I ask what is usually your what do you call it? Your neighbor's response to your sneezing?
I don't see them much.
You don't see your neighbors. No, I mean I'm not talking about your neighbors in your house. I'm talking about your school. You call him what? The one who sit next to you?
Oh, they don't really react.
Ah, okay. Oh, okay. Well, these days, not these days, but even in our days, if someone keeps sneezing, then we try to like make a big fuss out of it. Then I guess these days they make a bigger fuss out of this. Okay, fine. You done?
Oh,
Part B,
no,
yep.
I'm doing B.
Yeah, B is the real deal, like I said.
Is there a way to find area using vectors or?
Actually, yeah, so this is something I want to highlight to you. So when it comes to area ratio, right? So area ratio over here, um in fact the key concept is you make use of the properties of similar triangle properties. So you can use the length ratio, right? The length ratio, if the length ratio for if the length ratio for two triangles is 1 to 2, then the area ratio will be, you square it, right?
Yeah.
So it will be 1 to 4. So you make use of the similar triangle properties. So in a way, you have to uh, prove similar triangles, then you can make use of the similar triangle properties. So OPQ, where's OPQ? Let me see. Let's work on it together. OPQ. this one, this is OPQ, and this SPQ, SPQ. Wow. Yes. Looks like you need to prove this is your triangle 2, this is your triangle 1. So it looks like you need to prove it. Hmm?
Yeah, there's the common angle.
So do you think you want to assume in this case?
I think I can, but
Yeah, you can.
yeah.
I think for convenience sake, yes, you might just assume that hey, it's 1 to 2, but what about it turns out to be 1 to 1.5? Or it might not be similar. I mean, this triangle 1 might not be similar to triangle 2, but actually triangle 1 is actually similar to triangle 3.
Wait, wouldn't 1 be similar to the triangle 1 plus 2? Like 1.
Okay. 1 plus 2? I don't know. You need to you need to somehow prove it to me. Otherwise,
It's
oh yeah, yes,
OPQ
you're
similar
right.
to OSQ.
Yes. Actually, triangle 1 is actually similar to the triangle 1 plus 2. You're right. You see, in a way, right? You don't have to prove it. In fact, you have already proven it in your mind. Otherwise,
Yeah.
it's hard to move on, you know. Let's say if like you you have no confidence in their similarity, it's hard to move on. I just can't move on. I don't know why.
Okay.
Yeah, it's 1 and 2. Yeah. By a factor of 1 to 3, right?
Yeah.
Yeah. So in a way, this is 1 unit, then this is 3 when it comes to area. So if this is 1, then this has to be okay. So in a way, if this is 3 unit, right? If this is 1 unit, this has to be 2 unit lah. So in a way, this is 1 to 2, right?
Okay.
Yeah.
Yeah.
Okay, good. Yeah. OPQ to OST. We just did this,
Wait.
right? We just did this. So the length ratio is 1 to 3, so it's 1 to 9.
Okay.
Yeah, you just did it, right? So 1 to 3
Yeah.
is the length ratio.
Wait, wouldn't 1 to 2 be the length ratio for part I?
Per I is 1 to 2, right?
Isn't that the length ratio though?
Hold on. That okay. Uh,
Oh wait, no, it's not including the OPQ. Never mind.
yeah.
Okay.
Just now the area ratio is 1 to 3, right? If I'm not wrong.
Oh, which one?
Okay. I can. Okay. Never mind. Okay. Good that you asked this question. There is another way to do area ratio. Besides length ratio and then square it, you get area ratio. I'm going to describe it in more details. Okay, so you square the length ratio, you get area ratio. Okay, this is one technique. The other technique is I'm going to take this. I'm going to take this out. Let me erase it. I'm trying to. So this is one technique to prove area ratio. I mean to get area ratio. And another technique is this. Let me just crop this out first. Upload. Nope. let me see. Upload here. Upload my device. I need to go to desktop. Is this the one? So it's 8:35. Good. Let me just. Is there a way I can rotate? Rotate.
Oh, yeah.
Can you help me out if you know how to do it?
How do you wanna wait? What?
Rotate. I want it to be like this. Rotate it. No, resizing.
I don't know, but I can link stuff to it. That's so weird.
Oh yeah, maybe you're playing with the one my map stuff or something.
I thought that would be usually that's where the rotate.
Never
thing
mind. It's okay. I
Maybe
will do it with my other tool, and then I just get another image out. Don't worry. Yes, I need to rotate it for you to see. Otherwise, it's hard to see. Okay, let me upload another image. Good. I have another image ready. Okay, good. I don't need this. Here. Okay, so for this question, what you can do is, can you see the S, Q, O?
SQO, yeah.
And then this is your P, right? Yes. This is B, then this is 2B. Okay, looks like this is a bit off. So let me just make it more accurate. Otherwise, it doesn't look right to your brain. Okay, good. So to find the area of, so basically to find the area of OPQ, right? Over the area of triangle SPQ, right? What's the area formula for triangle? Half times base times height, right? Same thing.
Yeah.
Half times base times height, right? Okay. So what is the base for OPQ? OPQ is this one, right? B, right? So what's the height? This height, right?
Yeah.
Good. So
So
this is half times base times height. That will give you this area of triangle OPQ. So similarly, how do you get the SPQ? SPQ is this.
Oh.
So the base is 2B. The height is the same height. So in a way, you can actually see half gone, HH gone, B gone. So only 1 to 2. This is another way you can find the ratio of the ratio between these two triangles.
Okay.
Does this make sense to you?
Yeah.
Just now I approached this question from another angle. That way works. This way works as well. Okay. So in fact, besides you can use the length ratio, as you square it, you get the area ratio. This is another way. Okay, if they have the common height.
Wait, if it's common height.
Yeah, this is the common height.
Okay, but if it's common height, I thought we can't use the length ratio square.
Oh wait, that just now what I use, I did not use the. Just now what I use is you are telling me this one, the area of 1 is the area of 1. I mean the just now what I use is area of 1 over area of 1 plus 2 is 1 to 3.
Okay.
So what this means is if you give it a unit, this one is 1 unit. Okay?
Okay.
And then the whole thing is 3 unit.
Okay.
So isn't this 2 unit?
Yeah.
Yeah, so that's why how I get 1 to 2. I did not use this length ratio and equal to, I mean, you square the length ratio, you get area ratio. Just now. Let me pen it. Let me give you another example. So, what if I have this? Okay, I tell you, okay, this is triangle 1. Then you have this trapezium 2. Okay, I tell you their area ratio. The area ratio of triangle 1 to the area of triangle 1 plus 2. Triangle 1 plus trapezium 2. So that means the whole thing is 1 to 5. Okay?
Okay.
So if you assign the unit to this, so this will be 1U, right? And there will be 4U, right?
Yeah.
Yeah. So if they ask you for the area of this, then it's 1 to 4.
Okay.
Okay. So can you see how I got my answer just now?
Yeah, I can.
Yeah. Okay. Or you did not get this one, like just now.
Oh, I understand it. Yeah, I get it now.
Get it now. Okay, good. So, that means I have shown you 3 ways to get the area ratio. Okay?
Okay.
Okay. Is your screen too bright for you?
No, it's fine.
Okay. Okay, good. Next. Last one. Yes, this question is more interesting.
PQ.
Yeah.
PQ. Oh.
Looks like you somehow you have to prove it somehow. I don't know. You can use the common height.
Huh? Oh wait, are they both? Oh yeah, they both have the common height.
Yeah. So you can use common height technique. Yeah.
I need the base, right? PQ, which
So you
is
just pick this to this.
where's PQ? 2A. So 3A over 2A. 3 over 2. 2 over 3.
Never mind, you just make use of the half times base times height and just half times base times height. Just key in just sub in the values for base and height, and the common height they cancel each other out half. So it's just the ratio between the base. Yeah. Yep. Okay.
Okay.
Yeah. Yeah. This is the kind of question I regard interesting. Yeah. All right. Let's move on. Probably one last question. Interesting question.
Okay.
Interesting question. Just upload it somewhere and then I will move to that area.
Okay. This one comes with answers.
Okay, fine. Okay. It's good. It's good. It's good with answers, but we can do without as well.
Can you see? I uploaded on the left.
Sure. Yes.
Moving
Sure.
to the left.
Yeah. I can see your cursor is moving vigorously. All right. Good. Yes. So I will say uh, the part three A B, they are the more challenging ones, and then the rest they shouldn't pose any challenge to you. But I think even with the understanding just now, I think all these questions shouldn't pose any challenge to you.
BE is 205.
Okay, let me grab one more drink. While you're working on it, let me quickly go to the washroom. Yeah. You're working on the right hand side, right?
Yeah.
Oh, okay. OE. What did you say about OE? Hmm. Hmm. So just for your info, your answers here and here, they are both correct. But I think if you look at the answers from them, right, they would like to take out the common factor 1/4, and then you get 3p plus this q. And then for this, they like to take out the common factor 5/2, 2/5, yes. Then you end up with 3p plus q. So in a way, right, they like to get it into this format so that you can quickly see these two, right? They actually, I think they are parallel
Which
because,
one?
huh? If they are parallel because, um, because okay, this one,
Or they're the same except for the
yeah,
scalar.
yeah. So there is a scalar factor k, which if you want to write it, you can say OD is equal to K OE, you know, or in a
Okay.
way, K is equal to OD over OE, right? And K is a constant. Okay.
Okay.
I think most likely they will
I
ask
think that's a proof for
proof.
I OD
Yeah. Yeah. So basically, they will ask you to prove
also
their,
OE.
or they will ask you what are maybe the relationship between these 3 points. Okay. So in fact, you just need to prove that first they are parallel. Uh,
And they start from the
they
same
start from the
place,
same
is it?
point O, so they are collinear. Yeah.
Okay.
Yeah. Okay. So yeah. So I think I talk about to prove collinearity, you have to have two conditions, parallel and start from the same point.
Yeah.
Yeah. if you have parallel, right, it's not good enough. Because parallel can be OE, right? Then can be parallel, sorry. Then it can be CE, you know.
Wait, that wouldn't be parallel.
This one will be parallel because it's same point, right? Or N at the same point or something, but CD, you know. So parallel can be this, yeah. Okay. Or the other one is they might not need to start from the same point, or they go through the same point also can. In this case, go through the same point. Understand?
But if they go through
CE. Like, okay, it really depends. It really depends how you arrange them. So.
But going through the same point, isn't it just the same as they start from the same place?
I don't know. Maybe the E is here, you know, OE then OC. So over here you can say OC. EC, you know. Sorry. OE. So sorry. OE and EC. Yeah.
Oh, all right.
Yeah.
Okay.
Of course, you can use OC lah. In a way, you can plus these two, then you get OC. But what if you are just given OE and EC, then you can, right?
If there's a gap in between the two, they're not collinear.
Collinear is just cut. No, collinearity is continuous.
Is it? Okay.
Is it? I mean, must it be? Wait, the point they are actually not continuous. It's only continuous when you link them up. So continuity is not a must. Right.
So you mean if there's a line like this,
Okay.
they're collinear.
Hold on.
Here.
Wait. What is your point first, right? You
label them. Are they still collinear?
So you want to tell me this is O, this is E, then this is point what? This is point C, then D. Okay. So you want to prove whether they are collinear, right?
Yeah.
Collinearity is as long as they, you know. Collinearity is not about the continuity.
So it doesn't matter if they
as long as, okay, strictly speaking, collinear means they are on the same, okay, collinear means on the same path or line or something like that.
Okay.
The points are on the same path or line. Okay.
Wait, so doesn't that mean that the second rule doesn't apply all the time? They're going through the same point.
Actually, you can somehow prove it. Like, you know why? Because if you have OE, you have EC, you can find OC already. Then you can use. Let's say you have OE, you have EC, so you don't use the pass through the same point. You can somehow find OC, you know, because OC is equal to this. So once you get OC already, you can compare OE and OC, you know. You understand my point?
Yeah.
So then you can always go back to they start from the same point instead of they go through the same point. Or they go through, yeah. Okay?
Okay.
All right. Yeah. So we have proved that. Then, of course, area. OAD, ODC, same height. Use the same height. Okay? So it's 1 to 3, yeah?
Yeah.
CDE, CD. Oh, you need to connect it. OAD. Ooh. You use this as a
I think
reference.
this was the first part.
No, you use this as a reference. Use this as a reference. Because you have ODC, already, right? So you just compare triangle ODC to triangle CDE. Yeah. So you get this ratio out first.
It is.
So you can use same height. You can use same height. Yeah.
Yeah, but then I'll need DE for that.
What's that?
I'll need DE if I want to use the same.
Yeah, you need DE. But I thought you proved they are collinear, then you can somehow get it or cannot.
Yeah, I think I can. Using EB.
Yeah, you have this one, right? Yeah, this one.
I have EB and I also have OB.
Yeah, you have this. I have circle here. Can you see? So DE, OD is OE, right?
Yeah.
You have OE,
OE is.
you have OD. So you definitely have DE, right?
Yeah.
So where's your DE answer? Oh, OE is 2/5 that one. Then OD is 1/4. So basically this one and this one, right?
Yeah.
So use minus. So your P should be, wow, you're testing me. 1.2, 0.75, so 0.45 P, then 0.4 minus 0.4 minus 0.25, 0.15. So 5 Q. Of course, use calculator, yeah? So this is your DE, yeah? Okay? Okay, so you have DE, then you just take the common factor out, then you can, so common factor is 0.15, so it's 3P plus Q, yeah? So you take DE over, use the common height, this is OD, where's OD? This is OD, right? Which is 0.25 3P plus Q, so therefore 0.15 over 0.25. 0.53, 0.55, so it's 3 to 5. So this one is 3 unit. Are you following?
Yeah.
Okay, good. So this is 3 unit. This is 5 unit. Okay, so it's then you just use the so area OAD is 1U, right? And then ODC is 3U, right? So you just make it common, you know. So basically this is 15U. So if you get this into 15U, this one will be 9U, right?
Yeah.
So this will be 5U, right? So it's 5 over 9. Okay? So you need to use intermediate.
CDE over
CDE, yeah.
It should be 9 over 5.
Oh, then 9 over 5, yeah. Just have to be careful about this. Yeah.
Okay.
But somehow I think if you get 5 over 9, I think you just look at the size and then you know that you have to flip it. Okay? It doesn't make sense, right? Because clearly this one is bigger than this, right? Yeah. Okay, I think the rest should be pretty simple also. So yeah, I think it's a good session today, especially the second part of the lesson. Okay, for the area ratio. So I think I have taught you how to do the area ratio of two triangles. There are a few techniques. So this one being the last technique. Okay, use an intermediate. You use a reference. You use a reference triangle. Then okay. Okay, good. Any other question for me?
No.
Okay, if not, then I will just probably give you some homework for next week. Then I will upload to the same box.com link. Then you will just access it over there. They are on vectors, yeah. Something similar to this. Okay. Okay, thank you so much.